The first three patterns in the sequence are shown below. Each pattern consists of white squares and shaded squares. So you have pattern 1, 2, and 3. In pattern 1, you can see that it's a 3 by 3 with the shaded square in the top right and the diagonal going from top left to bottom right. And then you can see the same thing but with 4, 5. So then if we want to draw pattern 4 in the sequence, we should have also drawn the lines across here. That will take a good bit of time. So you want to do that with a ruler. So then this one will be 6 by 6, line going across, and a shaded square in the top right. So we'll have a look at part B here. So complete the table below to show the number of shaded squares and the total number of squares in the sequence. So here, the number of shaded squares in pattern 2 will be 5. The total number of squares will be 16. In 3, it will be, so shaded squares will be 6. Total number of squares will be 25. And then this will just be 7, so this must be 8. This is 5 squared. So this will have to be 6 squared. So this will have to be 7 squared, so 49. So we can see that this is n plus 2. So we do 3 plus 2 squared, which is 25, 4 plus 2 squared, which is 36, and then 5 plus 2 squared, which is 49. And then they're just asking us to give your answer in the last row in terms of n, where n is a natural number. So you can either do this using the formula or just by looking at it. So this is going to be the same, but plus 3, plus 3, plus 3, plus 3. So we could say this here is n plus 3, just to sort of describe the pattern that's going on. Okay, then for part C, in pattern K, the difference between the total number of squares and the number of shaded squares is 271. Show that this means that k squared plus 3k plus 1 is equal to 271. Okay, so the difference is something that we obtain by subtraction. So, for example, we always want to start with very simple examples. The difference between 5 and 2 is 3. So it's 5 minus 2 is 3. So total number of squares, that's going to be n plus 2. In this case, k. So it's going to be k plus 2 squared minus k plus 3. So I'm just copying from up here. We're replacing all the n's with k's because we are told in pattern k. And this will be equal to 271. So let's just work this out. So I'm going to do k plus 2 in a box here. K plus 2. I shall make this a little bit bigger here. So we have a box. So k plus 2, k plus 2. This will be k squared, 2k, 2k, and 4. So I just did the k plus 2 squared here. So k plus 2 squared is the same as k plus 2 by k plus 2, which we can either do in your head, if you're able to do that, or if you struggle with that, you can use the box method. So just for those that want to do it faster, what you have to do is square the first, so k squared, then do the first by the last, which is k by 2, 2k, then you double that, so k squared plus 4k, and then you just square the last, so k squared plus 4k plus 4, which is the same as we have here, because the two k's will go together. So k squared plus 4k plus 4 minus k plus 3 is equal to 271. Now what we have to do is just put the like terms together. So there's no more k squared, plus 4k minus k, that will be plus 3k. Or sorry, this here should be, because it's a minus, so this should have been put in brackets. So this here changes to a minus 3 actually. So then this will be 4 minus 3, that will be plus 1, is equal to 271, which is what we have there. So that's how we show that this phrase translates into this equation. Okay, so then for this one here, we have to solve this equation to work out the value of k. So even if you didn't get the last part, you could still do this part. That's often the case, where you don't necessarily need the previous part to answer. So even let's say you get stuck on C part 1, just keep on going with C part 2. So the way that we answer this is we need to recognize first that this is a quadratic. So we're going to have to put everything over to one side, make it equal to 0. So I'm going to say k squared plus 3k, and then I'm going to minus 271 from both sides, which should give me minus 270 here, is equal to 0. Now, whenever we want to answer a question like this, we have to use the minus b formula. So for factorizing quadratics, we use the box method. For solving quadratics, which is what we're doing here, solving, we want to use the minus b formula. So I'm going to get a, b, and c. So a is going to be 1 because it's 1k squared. B is going to be 3 because it's 3k. And c is going to be minus 270. So I'm going to do minus 3 plus minus 3 squared minus 4 by 1 by minus 270 all over 2 by 1. So that's our minus b formula, which you have in your formula book. So I'm going to have two answers here, so I'm going to have to write this out twice. So minus 3 plus the square of 3 squared minus 4 by 1 by minus 270 all over 2. That will give me an answer of 15. And then we always have to get our negative value, so I'm going to replace with a minus. We'll get minus 18. Now, this quadratic has two answers. That doesn't necessarily mean that we will have two answers to our question. The reason for that is we can't have a pattern minus 18. We can't go backwards in patterns. So this here cannot be an answer. So our value of k will be k is equal to 15.